Okay, so let me say a few things. If you are tuning in on YouTube because you missed class, I passed out these reference tables here, okay? And this announcement goes out to everybody. Keep these reference tables safe. You will need them. You will need them next week for the midterm exam, okay? Do not come next week and say, I forgot my reference tables, okay? Because I'm going to say, I've warned you last week that you need to bring them to the midterm exam. Yes? They are also available online. So if you misplace them, you can go to Canvas, and under week 5, they are available there, okay? So if you are online and you missed class and you didn't get your copy of the reference tables, you can go on Canvas and you can download the reference tables here and print them out yourself, okay? The reference tables online includes one more sheet of paper which we will make use of later on in the quarter, and when that time comes, I'll be sure to pass out that paper, okay? But for the midterm exam, you will need both of these sheets. Make sure you bring them next week, okay? If you say, I forgot them, I'm gonna say, that sucks for you, okay? So these are yours, yours to keep them safe. If you misplace them, it's your responsibility to go online and print out a new copy for yourself, okay? Next week we have the midterm exam. The midterm exam will cover everything that we've covered in this course, including the stuff we covered today. So today we are covering chapter 6 in the textbook, and so the midterm exam will cover chapters 1 through 6. As far as study guides and study practice goes, I recommend studying the practice quizzes that have been posted online. I feel like they have been representative of the quizzes that I've given, and they will be representative of the midterm, okay? There might be maybe just a small handful of questions on the midterm exam that are not very, very much alike to the practice quizzes, but there will only just be a few of those, okay? As far as the stuff we covered today for chapter 6, I have posted a set of practice problems for chapter 6 online as well, okay? So that covers all of the material. All of the material we've covered is covered in either older practice quizzes or the practice problem set that is available online, okay? The exam is written for 2 hours. It's all multiple choice. There's about 50 questions, okay? I believe it's plenty of time. And so we'll get started at 7 o'clock, and then if you finish early, you are free to go. We're not going to do anything after, okay? So we'll do that, okay? Are there any questions? Okay, so next week you are responsible for bringing your reference tables and your calculator, okay? Again, don't show up next week and say, I forgot my calculator or my calculator batteries die, okay? Make sure your calculator batteries are working and you have your reference tables. Oh, you are also allowed to have a note sheet, okay? The note sheet is allowed to be one full sheet of paper, but on the front side only, okay? Front side only. So I will be coming around, and so for the midterm I have to check your IDs and whatnot, so be sure you bring your ID, and during the ID check I'll also just be making sure that your note sheet is single-sided, okay? And so please be sure to bring your ID. This is something that the university asks that I do, and it's always awkward when a student does not bring his or her ID because because I'm responsible for making sure the person who takes the exam is the person who they say they are. So I end up having to take that person's picture, okay? So I'll have my like phone and I'll take you know, if you say, you know, and it's not, I'm not gonna do anything weird with it. It's just I just need to have a record of, you know, this is the person who took the exam, and then later on that person can bring an ID to verify what it is. So please, you know, just be sure you bring your photo ID next week, so we don't have to deal with this awkwardness. Okay, are there any questions? Okay, then today we'll cover Chapter 6, and we will make use of these tables that I just passed out, and we'll go from there. Okay, so Chapter 6 is about probability distributions. Okay. Specifically, we are dealing with the normal distribution and also later on the binomial distribution. Okay. And what these things are, what the normal distribution is and what the binomial distribution is, these are ways to model random events, the outcomes of random events, okay? So these distributions, or probability distributions, are used to model outcomes of random events. Okay, we have a question. You know, give me a second. Let me see if I can figure out how to do that. Is it on? Okay. It sounds like it's doing something. So, okay. I hope. Okay. You're welcome. So, probability distributions. These distributions are used to model outcomes of random events. Okay. So here's an example. Example of a random event. Where the outcome can be described with a normal distribution. Okay, and so let's see. Okay, so the example is, we will select a random male from, we'll say a random adult male from the United States. Okay, and the outcome we record is this person's height. Okay, all right. So this is a random event. Okay, because here we've got some kind of population of U.S. adult males. Okay, and we're just taking one person, and we want to know how tall are you, okay? All right, and so, you know, if we, the first time we do the measurement, which we will call X, could be, this guy could be 5'8", okay? And so that would be 68 inches. Okay? And then maybe another time, this person could be 6'1", okay? 6'1" inch. So that would be 73 inches tall. Okay? So I want you to think about, the heights of adult males. What do you think will be common heights that we observe? And what would be uncommon heights that we would observe? And what would be some heights that we would just not observe? Okay, or measurements that we would not observe. Okay? So let's just go through. So common heights we might observe. Anywhere from, what do you say? 5, yeah, maybe 5'8" to 6 feet tall, something around there. Those would be pretty common, right? Okay, I'm just kind of arbitrarily saying stuff, okay? So 5'8" to 6 feet is pretty common, okay? All right, less common, but definitely possible would be what? Like 5'5". What's that? 5'2". Yeah, 5'2", sure. 6'5", and 6'7". Less common, okay, but definitely there, okay. All right, and then just really like not really possible will be things like 10 feet tall, okay. With the exception of just a very small minority, just a very exceptionally rare, I should say, maybe not possible, but exceptionally rare would be something like 3 feet tall or something that would be exceptionally rare for an adult male. Okay. And then 10 feet, 12 feet, we're just not going to see heights like this. Okay. All right. So this is just kind of our intuitive sense. Just our quote intuitive sense of heights. Okay. And this idea of what's common and what's less common and what's not really possible can be modeled by what we call the normal distribution, okay? So I just want to make sure everybody's got this down before I flip to the next slide. Yes, a question?
What does that say? Our something sense of heights?
Just our intuitive sense. Just kind of from our experience of observing the world, right? Whereas, if we said, what are common and uncommon heights of people from Russia, we would have a hard time answering this because probably our experience is, we probably have not had very much experience seeing people from Russia, right? Unless you've lived in the country for a while or something like that. But we probably have a sense that, oh, well, they're also humans, and so their heights are probably similar, but maybe they're taller, maybe they're shorter. We don't. It's kind of hard to gauge that. Okay. Okay. So I'm going to flip to the next slide. All right. So again, this idea of these heights kind of in this range are quite common, and these heights out here are less common. And then as we get further away from this idea of what's kind of like average, it becomes less and less common. And so our normal distribution looks a lot like a hill, okay? And this should not hop up here. Okay, and basically what you have is that the height represents how common it is. Okay, so it's very much like a histogram, but just represented with a smooth curve. Okay, so the height. So I shouldn't say, I don't want you to mix up the height. So just kind of the vertical axis represents how common a measurement is. Okay, and then our horizontal axis represents the measurement. Okay. So in our case, the thing we're measuring would be the height of a random adult male, US. Okay, and so right around here, I'm going to just kind of put the average height's around 5'9", 5'10". Okay, I'm going to just split the difference and say 69.5. Okay, so this is kind of the average height of US males. This goes in the middle. Okay, and I'm just going to kind of mark off a few. These are supposed to be equally spaced out. And maybe I'm not doing a good job, but okay. And so here I'm going to go up about 3 inches, so that will take me to 72.5, and 3 inches below will take me to 66.5. Okay, and so what this, so kind of. This would be basically around 5'6.5", 5'7"-ish to about 6 feet, 6'1", something around there. These are saying this is the tallest part of the hill, right? This means heights from here to here are the most common, okay? Because this is the tallest part of the hill. All right, so we have the tallest part of the hill here. So this says heights in this range are most common. Okay, and then if I go out 3 standard deviations, that would take me to, well, so I'm just saying each of these breaks are 3 inches here. Okay, so this would take me to 63.5, 60.5. Okay, and this would take me to 75.5, and what would this be out here? 78.5, right? I'm just saying each of these kind of breaks are 3 inches here. Okay, all right, and so that says, you know, from here to here, these are, you know, people in these regions also exist, but these are, you know, kind of less common heights. And these are less common tall heights. But these ones are tall, and these ones would be considered short. Okay, or shorter and taller. I don't want to say short or anything. Okay, and then, you know, once the line gets pretty down here, okay, it's pretty much at the on the line here. This out here pretty much just means, okay, since it's now like pretty much flat on the bottom here, this one pretty much says like hardly anyone is out here. Okay. So hardly anyone is out here this tall, and hardly anyone out here this short. Okay. So can we see how a hill can kind of represent the heights of people? She's saying that heights in this center region are most common. Heights higher than that are less common, but sure, they exist. Heights lower than that, less common, but they exist. Heights way out here and heights way down here, you hardly have anyone out there. Only extreme people. Okay, so probably professional athletes might be out here. Okay, because not everyone's a professional athlete, and the ones who are really, really tall, they're the ones who get the chance to become professional athletes, right? And well, even then, they have to work really hard to compete. I shouldn't say just it's not just height; it's height and athletic ability. But height is definitely helpful, especially in basketball and stuff like that. Okay, so we can talk about this. Okay, let's see. Okay, so I'm going to flip to the next slide, and I'm going to draw the same thing here. And the idea here is that if I were to shade everything, if I shaded everything underneath the hill, then the amount I have shaded would be 100%, okay? So if I shade everything underneath the hill, I'm going to call it the curve instead of the hill. Then I have shaded 100%, or the proportion I've shaded is just 1. Okay, so we have to get used to switching between percentages and decimals. So if I shade everything underneath the curve, then I've shaded, the amount I've shaded is 1. Okay? All right, so here's a question. If I draw a vertical line right here, and I shade everything to the left, how much will I have shaded? 0.5, okay? And on the standard normal curve, the number in the center is 0, okay? So this is what we call the standard normal. The number in the center is 0, okay? And so if I shade everything to the left, if I draw a vertical line at 0, okay, so I draw a vertical line at 0, and shade everything to the left of 0, the amount I have shaded is 0.5. Okay? All right. And if we take a look at table 2, that's what this says. Okay? So you're going to have to flip it over to the side that says A3. Okay? And you will notice that in the top left corner, so if I go to page A3 and I look in this top left corner, right here, okay, we see that the top left corner, the number in there is 0.5, okay? And what that says is that if I look up what we call z equal to 0.00, okay, 0.00 is made up of the row, is basically 0.0 plus 0.00, right? Okay, so, which is basically just 0, okay? So I'm going at the row 0, I'm looking at the row 0 and the column 0.00, and it says that number right there is 0.500 or 0.5, okay? So this basically is z is equal to 0. Then the area to the left of 0 is 0.5, okay? Or, 0.5000, which is basically equal to 0.5, or 50%. Okay, that's all we're saying here. That's too dark. So that area is 0.5. That's all we're saying. This area here is 0.5. Simple enough, right? No? Are we not getting this? So here's a hill. Okay, everything under the hill is, if I shade everything under the hill, then I've shaded 100%. Okay? But I'm going to draw a vertical line right here in the middle. Okay, and in the standard normal curve, the middle is at 0. Okay, and so what our standard normal table tells us is that if we look up the number 0, okay, which is found at the intersection of 0.0 and 0.00, okay, that number is 0.5 right here. And that says if I shade everything to the left of 0, which is the exact same thing as 0.00, okay? If I shade everything to the left of 0, the amount I've shaded is 0.5. Yeah?
So this chart has nothing to do with this chart up here, because this shade is shaded more towards the right, whereas that one is in the middle.
Uh-huh. Okay. No. This is just a general diagram of telling you that we're shading everything to the left. Okay?
It has nothing to do with that.
No, it is this. It's just you have to pretend that this letter Z can slide along the axis, okay? And so we have slid it so it's directly under the peak of the hill, okay? So it is that picture, it's just you have to pretend that you can take this letter Z and slide it left and right, and you're shading more or less, okay? All right, is this okay? Okay, so let's just practice using the table a tiny bit, okay? All right, and so here, the center is always 0, but let's say I draw a line out at 1.23, okay? So I'm going to go to the table, and what I'm going to do is I'm going to look up the row 1.2 and the column 0.03. Okay, so I'm just going to chop this out. Okay, so 1.23, so z equal to 1.23 can be written as 1.2 plus 0.03, right? Okay, and it's not, so what we're going to do is we're going to go to the row 1.2 and the column 0.03, and so we find this number. Yeah?
So why do we go to the column 0.03?
Because I'm looking up the number 1.23, which if we had to break it out into two parts is 1.2 and 0.03. put these together, okay, then we get 1.23. Okay?
Or we should just divide it in half.
No, well, dividing in half means I would get 0.615. Okay? No, we're splitting it into two parts. That's not dividing in half. Okay? So this is 1.2 and 03. Okay? So that's 0.8907. So if I shade everything to the left, then the amount I've shaded over here is 0.8907. Is that okay? All right, here's a question. How much is shaded in magenta? Okay. So shaded in green, we know is 0.8907, okay? How much in magenta? Exactly. So we know that we know that everything has to add up to 0, right? So 0.8907 plus the magenta part must equal 1 if I add these two parts together, because everything adds up to 1, okay? So then that means magenta is equal to 1 minus 0.8907, and so that gives me 0.1093. Right? So this part is 0.1093, okay? So this magenta, so, if somebody says, what percentage is less than z equal to 1.23, the answer there is 89.07%. And if somebody asks, what percentage is greater or more than z equal to 1.23, the answer there is 10.93%. I want to make sure everyone's okay with the use of the table here. We're okay here? Yes? No? No? Okay. Where are we getting lost here? Who's feeling not so good about this? Okay.
Let's start with the magenta of 1 minus 0.6.
Okay, sure. So you're okay with this part being 0.8907. Okay. So what do we know? If I shade everything underneath the curve, how much have I shaded? I've shaded 100%, right? So green and magenta added together make 100%. Is that part okay? Okay, so green and magenta, so instead of saying 100%, I could just say green and magenta make 1. Okay, so that's what I basically have here. I've got 0.8, so I'm going to just write that here. Green plus magenta equals 1. Is that okay? All right, so I know my green area is 0.8907. That's okay. Is that okay? Yes, okay. So I'm replacing green with 0.8907. So I have 0.8907 plus the magenta is equal to 1. Okay? And then so just using simple algebra, if I want to get the magenta area, I subtract 0.8907 from both sides, and that would leave me magenta on this side, and on the right side I would get 1 minus 0.8907. Okay? And then so that's how I know that magenta is equal to 0.1093. All right? Is that okay with everybody? Okay. Are we feeling about okay with this? Okay, so let me just give you just a a couple quick drills here of using the table and finding some values here, okay? So I'm going to draw all right, so I'm going to say negative 1.3 and then I will ask all right, so what is the area of green? What is the area of magenta? Okay, and then I'll draw another one out here. So I'm going to give you a few of these. Let's see. Okay. What is the area of red? Okay, so take a minute or so to get these values, and I'll go over our answers. Okay, if you're watching on YouTube, you can pause the video here to look up your answers here. Okay, so let's talk about this. Okay, so here we've got z is equal to negative 1.30, okay? So what we're going to do is we're going to split up negative 1.30 into negative 1.3 and then 0.00, okay? So we're just taking that second decimal and we're moving that over there. And so we go to our table, we go to the negative side, and we're going to go to negative 1.3 in the column 0.00, and the number I have there is 0.0968, okay? So from the table always gives me the area to the left, okay? So just keep that in mind. Table will always give the area to the left of z. So we looked up z equal negative 1.30, and that number is 0.0968. Okay, so right here I've got 0.0968. So what is the area of magenta? Okay, well I know that's going to be 1 minus 0.0968. And I get 0.9032. Okay, great. Okay, yes, question in the back.
How do you know they go to 0.00 as a column?
Well, if we went to any other column, okay, that would be a different number. Okay, so if I went to negative 1.3 and this column 0.05, that would be negative 1.35. Negative 1.35 would be split into the row negative 1.3
Okay.
and then column 0.05. Okay? Yeah.
So the column is a determining factor of the decimal place, later decimal place.
Yeah, the 10th decimal, the 10th place is the row, and then the 100th place is the column. Okay?
Thanks.
Okay. So next, we're at 1.07. Okay, so I'm going to just go to the positive side. I'm going to go to what? The row 1.0 and the column 0.07, right? So this 1.07 becomes 1.0 for the row, and then the column will be 0.07. So I look that up, and I get 0.8577. So the area of red is going to be 0.8577, and the area of yellow is going to be 1 minus 0.8577, 0.1423. Okay, another question in the back.
Oh no, I was gonna say that number.
Okay, great. Okay, feeling okay about this? All right. We have also what's called the reverse reading of the table, okay? Now, note, I'm saying this is the reverse reading of the table, but you're never going to have a problem that says, okay, now you're doing the reverse reading of the table, okay? So it's not like you get a heads up in the problem. You've got to read the problem and figure out whether you're going the regular, the forward reading, or the, quote, reverse reading, okay? All right, this is how the reverse reading of the table works, okay? What if I draw this picture and I say, hey, the area that I've shaded here, okay, my shaded area is equal to 0.5. And then I said, where did I draw this line? Okay, where did I draw the line? Okay, this is, and you would tell me I drew the line at z equal to 0, right? So here the given information is the area, and the requested information is the location of the line. Okay, whereas before I gave you the location of the line, I said z is here, tell me how much is in the area. Okay, this time this is the given information. Okay, and then we want to know where z is. All right, so let's just try another our hand at another one of these. Okay. Okay. So where is z? Okay, so don't shout out your answer. Okay, we'll give everybody a moment to try to find where z is supposed to be. Okay, how are you guys doing? You guys got it? Okay, so what's my answer? 0.86, right? Z is at 0.86. Because if I look up if I look up 0.8 and I go to the column 0.06, the area located there is 0.8051, okay? So in this case, we're going to go through our table and we're going to look through all of these numbers and find, hey, this is the number I'm looking for, 0.8051 here. That corresponds to 0.8 in the row, 0.06 in the column. So where I've drawn the line is 0.86. We do not do, hey, I'm going to look up 0.8 and look up 0.00 or 0.01 or any of these other numbers, okay? We're looking at what number gives me 0.8051. Is that okay? All right. So a lot of times, in a problem, it's not going to say something like, hey, the area to the left is 0.8051. It'll say something like the area to the left is 70%, or the area to the left, 30% is below this number, or 42% is below some number, okay? It won't give you out to 4 decimals, okay? So I'm going to, I will say, where is Z so that there is, let's say, 20% 20% shaded to the left. Okay, and so in this case, you got to turn 20% into a decimal, and you're probably not going to find 20% exactly in the table. You're going to have to then find the number that's closest to 20%, the number that's closest to 20%, even if it's not 20% exactly, and that's okay. You just got to take the number that's the closest. Okay, I'll pause the video here, and I just want to see if you guys can find this solution. Okay, so I'll try drawing a picture here. Let's see. So if I'm going to have 20% to the left, is that number going to be greater than 0 or less than 0? Less than 0, right? Because at 0, I've got 50% shaded to the left. So I'm going to be somewhere over here, which means my number is negative. And that means this area here is something close to 0.20. Okay, so we want to find the area closest to 0.2000. Okay, so I go to my table. I know I'm on the negative side, and I'm going to look through all of these numbers. They're all in order, so it's not so bad. Okay, and I look and I say, hey, what's the number that's closest to 0.200? Okay, and that number looks to be this one right here. Okay, 0.2005. That's as close as I can get to 0.20. Okay, it's a little bit more than 20%, but I think we can live with that. All right, and so this is equal to, the row is negative 0.8, and the column is 0.04. Okay, so when I'm looking through the thing, the number I find is 0.2005. That's in the row, negative 0.8, and the column 0.04. So where have I drawn this? I have Z at equal to negative 0.84. Is that okay? Yes, question.
Yeah, why did you look in the negative section? Sorry, I missed that.
Yeah, okay. So, well, let's just think, right? So if 0 is in the center here, all right, did that answer your question already? Okay, okay. All right, yeah, because At 0, I'm at 0.5, and so if I have anything shaded, the amount shaded is less than 0.5, I know I'm on the negative side. And if the amount I've shaded is more than 0.5, I know I'm on the positive side. Yes, question?
But how do you know you're at the 0.5? Isn't that 100%?
I'm sorry? Okay, okay. Yes? This one? 0.2005? Yeah, I'm looking, so I'm not going to find, so, you know, I'm not going to find 0.2000 exactly in the table. Maybe. We might find that number exactly, but we might not, okay? And if we don't find that number exactly, you just got to take the one that's closest to it, okay? So, you know, sometimes you get lucky and you get the number exactly that you're looking for. Sometimes you don't get the number exactly, and so you just take what's closest to it, okay? Yeah?
Is there like a way to find where the closest to 2.0 is, or do you just look throughout the whole table?
Yeah, you got to look through the whole table. You're going to generally find, you know, 0.20 is between two numbers, right? So, you know, when you get to the table, you're like, okay, I'm looking for 20%, which is 0.20, and that's going to be between this number and this number, 0.1977 and 0.2005, okay? Between these two numbers, which one's closer, okay? You know, I can tell just by looking at it that this one's closer. But, you know, if you're not sure, you can always do 0.2005 minus 0.2. Okay, that's off by 0.0005. 0.2 minus the other number, 0.1977, that's off by 0.0023. So this one's off by more, therefore this one is closer, okay? But yeah, you know, if I said, what corresponds to 3%? Okay, we'd have to look through all of these numbers and find the number that's closest to 3%. Okay, so 3% would be 0.03, and I've got 0.0294 and 0.0301 and 0.0307. The closest one is this one, 0.0301. That's the closest number to 3%, and that would be negative 1.88. Okay, for 3% there. Okay, so let's just do one more of these, and then we'll take a short break. Okay, I'll say you know, what z corresponds to the I will say top 7%. Corresponds to the top 7%. Okay, so if I draw a picture, I'm looking at the top 7%. So that means the area shaded up here is 7% or 0.07. Okay, do we have an answer? 1.48. Okay. So the top 7% means, so I guess before I write out 1.48, that means the area to the left, if I've got 7% of here, how much do I have over here? I've got 93% or 0.93, right? Okay, so we're going to go through the entire table looking for the number closest to 0.93. You know, what is closest to 0.93? Okay, and then looking through all of those numbers, the closest number I can find is 0.9306. And so that's going to be in the row 1.4 and the column 0.08. So I know z is equal to 1.48. Okay. I mean, I guess you're faced with a choice. Is it 0.9306 or do I choose 0.9292? Okay. Well, 0.9292 is off by 8 10,000ths, and 0.9306 is off by 6 10,000ths. So this one's off by 6, this one's off by 8. We're going to choose this one. Yeah, question.
How exactly did you find it was 0.93?
Well, I know everything adds up to 100%, right? So if I got 7% up here, how much do I have down below? 0.93, right? Okay. So, and I know the table, and the reason why I want to look up 0.93 is because I know the table always gives me the area to the left. Okay. I can never look up the area to the right in the table. So if it says something like the top 7%, you have to understand that's the area to the right, and then you have to then convert it to say, hey, the area to the left is 0.93. We're going to use that. Okay? All right, why don't we take a 10-minute break here?